Hello, hello to my Algebra 2 students. While I am away in California, I made this video for you guys so that you could continue learning. So I'd really like your full attention, and I appreciate how respectful you are being of the substitute. It was very nice for her to come in and help me out. Today our objective is going to be that students will be able to write the equation of a function given a graph by identifying the transformation. So we've been talking about the transformations, and now we're going to look at, well, what if I was given a graph and I had to write the equation? Your homework is to finish the activity that you receive in class. So you should all have something that looks like this: transformations of parent functions, characteristics of graph, and writing equations given a graph. So we are given this graph, and we need to identify what the equation of it is. Well, this is just a linear function, right? We've done these a lot, so we're starting very simple. Let's talk about what the domain and range are. Domain, we're going to look at which x values. We're going to say, well, let's see, if it keeps going forever and ever, what domain values would we have? Would I put x is greater than or x is less than or something like that? No, I don't even do that, right? I just say all real numbers. Good. And then the range, what do you guys think the range is? All right, all real numbers. Sounds good. So the equation is y equals, or f of x equals. Let's go ahead and use f of x. So y equals mx plus b. Let's find our slope. I see a point here. Oh no, it's very hard to see a point that's actually hitting, I think this is one. -2, 1. Correct me if I'm incorrect. So 1, 2, 3, 1. I'm pretty sure we're going down 3, right 1. We always want to move to the right. Sometimes students will do this and they'll go up and back, and that's fine too. It would just be up 3 and -1. So +3, -1, it would still be negative. Just be careful. If we look at this, it's a negative slope. So we have -3/1, or -3 slope. And we want to look at our y-intercept. Y-intercept is +1. So if we look at this in terms of transformations, our parent function started at 0, 0 with a slope of 1. Our parent function was y equals x. And a couple things happened. It shifted up 1. So I'm going to go and take this line that I just drew. Is it going to... the whole line's not going to come, but let's do half of it. Okay, so I take this line, y equals x, I shift it up 1. What else happened? It definitely reflected. Which way did it reflect? Over the x-axis or the y-axis? Aha! Big question here. I kind of see it reflecting over the y-axis, but maybe it's over the x-axis. You know what? Actually, in this case, it doesn't matter. Either one works. So, hold on one second. Let me pause this to reflect it. Okay, that was just too cool. I have to show you. I have to do it with you watching. Okay, so I decided to transform it, and I'm going to mirror it in the y-axis. Check it out. Is that not really cool? That is really cool. Okay. Now, in this case, we don't have an inside or an outside. It really doesn't matter because this is symmetrical about the origin. Well, is that correct? I don't want to misquote something. Okay, but if I take this, is it going to be a object? Okay, so I now have it reflected, so now we're going, oh, they're connected. That's okay, ignore that other half. Right here. Now there's something else that happened. So we did two things. We shifted up 1, we reflected over the y-axis in this case, but it could have just as easily been the x-axis. And there's one last thing we need to do, and that is stretch by a factor of 3. So instead of going over 1, up 1, now I want to go over 1, up 3. So up 1, 2, 3. Now notice my y-intercept is changing as I'm shifting, so I have to, if I was not using technology, it would be a little easier to see. But that would get me my equation. That was a little odd. All right, let's try one that's not a linear function. All right, here you have to first identify what is your parent. What is your parent function? And I have the parent functions over there on the cabinet. So you can look and see, okay, yeah, that's a parabola. I learned that a while back. So that's a quadratic. And the parent function for that would be y equals x squared. If I have something on the inside, I want to say, okay, something that goes on the inside would need to go in parentheses, right? And we always want to do the opposite of whatever the right or left shift was. And then out here, we're going to have our up or down. Out here, we would have if it reflected over the x-axis and if there's any stretch or compress. So let's go and see what happened to our function. So I want to check out the vertex. If the vertex started here, I definitely shifted right one, down one. So right one and down one. So let's write the vertex, positive one, negative one. So negative one is our up or down shift, and that goes out here. Our positive one, we have to be careful because we have to take the opposite of that and make it our inside, horizontal shift. Did it reflect over the x-axis? Did it do this? Yeah, obviously, no, it did not. Okay, so let's see. What else? Oh, we need to check and see if it's stretched at all. So originally the dimensions were go over 1, and 1 squared is 1. Over 2, 2 squared is 4. So let's see, 1, 2, 3, 4. Yep, it looks like the original dimensions are still in effect. Over back to negative 2 squared is 1, 2, 3, 4. So we still have the same dimensions. There isn't any stretch. So this would be our equation. Oh, I wanted to use f of x. X minus 1 in parentheses squared minus 1. All right, our domain and range. Take a second, talk to your groups. I'm going to hit pause, and you guys decide what is the domain and range of this function, and then we'll hit play again and see if you guys got it. All right, hit pause. Thank you. All right, so you should have already discussed with your groups. We could hear from students right now, but the domain in this case, oh, I'm sorry if I'm saying hear from students. So let's check and make sure. What do you guys think? What do you think? Okay. All real numbers, and the range would be only y's that are greater than or equal to negative 1. Sorry. All right. So that would be writing the equation and talking about the domain and range. Let's try another one. Actually, I want you guys to try this one all on your own. We just did one just like this. So I'm going to hit pause. You guys, or Miss Huffman, if you could hit pause for me too, that would be great. You guys try this one. Talk in your groups. Don't talk about what's for lunch or who's going to the prom with who, or I guess it's homecoming. But talk about the math. All right. Go ahead and hit pause. Thanks. All right. So the answer would be this. Check and see. Did I make any mistakes? Did you make any mistakes? Do we agree? All right. If you have a question, you can hit pause, talk to each other. You can answer each other's questions, or Ms. Hoffman can help and answer your questions. All right. Next one. This is a different parent function, right? What is this called? Yes, it is an absolute value function. So our parent function is this, absolute value of x. Now we want to think about do we have any horizontal shifts? No, our vertex stayed right there and didn't shift at all horizontally. But it did have a vertical shift. So let's identify the vertex. 0, 3. So the 0 tells me my horizontal shift. So really nothing changes on the inside, but here on the outside we are shifting up 3. Did anything else happen? Let's check our dimensions. I go up 1 over 1, up 1 over 1, up 1 over 1. It looks like the slope here is 1, so our stretch didn't increase or decrease at all. We didn't compress or stretch. And was there any reflection over the x-axis? I'm definitely not pointing down. Now, could there have been a reflection about the y-axis? Could I have reflected this about the y-axis? Would I know if I reflected about the y-axis? I wouldn't. Huh, weird. Okay. All right. Now, we're not going to put a reflection in there, but if it reflected over the y-axis, we're going to put it on the inside. All right, I'm going to say f of x. Wow. Oops. All right. I was going to try and be fancy. I'll stop trying to be fancy. Then f of x equals absolute value of x plus 3. All right, so that would be our function, our domain, all the numbers, our range, y's greater than or equal to 3. All right, cool. Let's try another one. All right, I want you guys to try this one on your own. Notice there's some things happening here. Be careful. All right, go ahead, hit pause, Ms. Hoffman, thank you, and let these guys try it on their own. All right, so this is the answer that I get. Double check, make sure I didn't make any mistakes. Notice if you put x minus 4, I'd say that's the number one mistake the students have made in the past. That forgetting that when I shift horizontally, I have to do the opposite. And if we think about this, if I plug in a negative 4 here, negative 4 plus 4 brings me back to 0. So that gives me my vertex. So I have to do the opposite in here to get me back if I'm performing this operation before I do the absolute value. And notice the other key difference here is because it reflected over the x-axis, now my range is y is less than or equal to. So now it's all values less than. All right, so key difference right here. All right, do we have another one to try? I want to say this is the last one. Yep, it is. Okay, so this is the last one I'm going to really help you guys on. And then the last, well, actually, I don't really need to help you. I want you guys to predict. I think you guys can get this. Notice it's a new parent function. Decide what your parent function is. Think about your horizontal and vertical shifts and where they go. And think about what the dimensions are, like what the original units are. Go over 1, and what's the square root of 1? Go over 4, sorry, what's the square root of 4? Alright, so think about that and try it. Try it on your own. You guys are brilliant, remember? Alright, go ahead and hit pause. Thank you. Alright, you should have had some time to try this one. So our this is a square root function. I'm using f of x. If you use g or h, it doesn't matter. Alright, so our parent function is the square root function. And the dimensions of the square root function was square root of 0, 0, square root of 1 is 1, square root of 4 is 2. So it still has these same dimensions. There was no stretch. Also, there was no reflection. It's not doing this. It didn't reflect over the x-axis or the y-axis. So we just need to worry about our horizontal translation and our vertical translation. So horizontal, we want to do the opposite on the inside. So x plus 3 on the inside. And then plus 2 on the outside, which tells us it shifted up 2 units. So that would be our function. And you guys probably already got that because you guys are brilliant. All right, and now our domain and range, in this case, neither of them are all real numbers. Our domain is going to be, we're going to be walking on the domain and say, okay, well, at -3 my function starts and it continues for all these numbers greater than or equal to -3. So x is greater than or equal to -3. And the y's that we're using, we're not using any of these down here, but we start using right here at 2 and increase forever. Because there should be an arrow there. So go ahead and put an arrow. So all y's greater than or equal to +2. All right. So there are about 3, 6, 9. There are 9 problems for you to do. Actually, one's an example. So I did one of the examples. Sorry, you can't see that. The parent function. So I first identified the parent function, and then I wrote the graph of the transform function. Notice this has all 4 things. It reflected over the x-axis, so it's opening down. It's stretched by a factor of 2. So instead of going over 1 down 1, I went over 1 down 2, so it's doubled. Instead of going over 2, what's 2 squared? 4. Instead of going over down 4, it went down 1, 2, 3, 4, 5, 6, 7, 8. So it doubled, and that's what that 2 is about. It shifted the opposite of that, so to the right 3, right, to the right 3, my vertex, and then my vertex shifted up 6. So that is how I got that equation, and you guys are going to do that for all of the rest. I'm going to ask you again to pause this, have some time to try it. When everyone has finished the next 2, we can check our answers, and then whatever you don't finish in class is for homework. Alright, well thank you for watching this video, and thank you Ms. Huffman for all of your pausing, unless a student volunteered and a student was pausing. Thank you guys. I appreciate you still learning while I'm busy having fun in California with my family. Alright, I'll see you guys on Tuesday. Okay, bye.